Good evening, everyone.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening,
Good
ma'am.
evening, ma'am.
Good evening, ma'am.
Very good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, ma'am.
Ma'am, you are on mute.
Okay, hope this is clear now. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, so just to
Yes, ma'am.
1 second, I think there are some ground rules I would like to this one. This Xiaomi, please stop writing on my presentation. I think Prashant, can you stop people from writing on my presentation? I think this,
Yeah, ma'am. I'm checking it.
Yeah?
Give me a minute. Yeah.
this is not a good behavior, whoever is doing it. Okay, please disable the annotation for okay. Right. Thank you. And AS, I would strongly recommend that people use the chat box to ask your questions. Okay. This tutorial is on permutations, combinations, and we will mainly on permutation and combination. And we will try and touch upon a few probability questions.
Ma'am, is this session for statistics?
Yes.
Ma'am, when will be the other three?
I think that other people can answer that. This session is for the statistics for data science 1. Okay. And this tutorial is going to be a revision session on permutations, combinations, and a probability. I don't think why you need tech code for the slides and everything. The slides are already available for registered students.
Ma'am, can I leave because I have not opted the statistics course for the
people who have not opted can always leave. I think we want to start ahead. So
Thank you, ma'am. Okay, ma'am, I am leaving, ma'am.
Yeah,
Okay,
I would request only those of you who think this would be of any use to them to stay here. The other request I have, please use the chat box to ask any queries, because we have very little time. So we would like to maximize this for those who are interested. Okay. And the third thing is, I think this is again for people. Let's not distract ourselves by knowing whether you want a tech code for the slides or whether you want a PDF of the slide or anything of this kind. The purpose of the session is very, very clear. This session is a tutorial wherein we revise concepts from the week of where we dealt with permutations, combinations, and probability. Whether it would be helpful or not, I am not going to comment on that at this point of time. I think you all know the purpose of these revision sessions and their need for it. Okay. So let's start. Now, again, what am I going to do in this session is we are going to understand, again, it's as I said, it's a revision session on permutations and combinations, because the first thing is, why do we need permutation and combination at all? The whole purpose of learning permutation and combination is, can we just restrict even the chat messages to only this session, please? Let's have some ground rules. Okay. Let's restrict the chat messages only for this session. Any other queries, you have forum where you can discuss that. This is not a place where I want a one-on-one conversation on something that is other than the chat session, the tutorial. Okay. Now, I do not know whether this is for reattempt or anything. This is for doubts only. This is general. This is, I repeat, this is only for, this is a revision or a tutorial on permutation and combination. There has to be some ground rules. The first ground rule is please use the chat box to ask questions on permutations, combinations, and please restrict that only to this session. The reason is I am going through the chats, and when there is something which is not relevant, it distracts the session. And I'm sure all of you are here to learn about permutation and combination. So can we just start with this discipline that we are going to use the chat box only for permutation and combination, please?
Yes, ma'am.
Thank you all for your understanding.
Yes, ma'am.
Yes, ma'am.
The first thing that we are going to understand here is we are going to revise these concepts of permutation and combination. The first thing why we require permutation and combination is when you go back and when you are going to understand, and if you have come up to the probability stage, you'll know that whenever I want to find probability of what I call events, again, I have a sense of counting there. So this permutation and combination is basically I'm trying to count. So towards that, I need to understand what is the base, what I term as basic principles of counting. Once I learn about the basic principles of counting and how to count, and by count, I do not mean counting 1, 2, 3, but counting the number of outcomes in a particular instance. That is what I mean by counting. We will understand what is an ordered counting with order and counting with regard, without regard to order. So that is one is what we call permutation and one we call combination. So in today's tutorial, we are going to focus on certain scenarios wherein we'll understand when the question wants us to find a permutation and when the question wants to find a combination. And we will finally end the session by using these concepts to compute probability. So this is the agenda for today's session. If there are any clarifications regarding the objectives, you please use the chat box and I will attempt to answer everything that is in the chat box. Once again, my request is please restrict and use the chat box only for comments and doubts with respect to the session. Okay. So now let's start by what is a basic understanding of counting. As you may have seen in the lectures, when I talk about the basic principle of counting, we mentioned about what we say is an addition rule of counting and a multiplication rule of counting. Now, the addition rule of counting is if there are, we will be doing a few exercises or examples, but again, this is, so we will try and see how to do, we will try and look at scenario concepts and all of that. Okay, that is what we are trying to do. So now, first of all, let's start with the basic of the rule of counting. Now, addition rule of counting is, so let me start with an example to understand what is an addition rule of counting. So let me ask you this question. Suppose I give you suppose you have 2 fruit baskets. And please listen to the question carefully. I have 2 fruit baskets, each basket containing different types of fruit. So let me call this as basket 1 and this is as basket 2. This is basket 1. This is basket 2. In this basket, I have some apples. I have an apple, orange, and I have, say, banana. In this, I have mangoes and say I have grapes. Okay? Right? Okay? So now, I'm going to tell you that suppose you want to choose a fruit either from the first basket or second basket. Listen to me very carefully. I'm saying that if I tell you that you have to choose a fruit either from first basket, or from second basket, that is either from the first basket or from the second basket, how many days can you do it?
5.
And please use the chat box. Yeah, 5. 5 is the right answer, but why 5? What are you using here? You're using the addition rule of counting. I can choose from the first basket in 3 ways, in the second basket in 2 ways. So together I can do it, and these are independent, so I can do it in 5 ways. Now suppose I tweak the question and I say that choose a fruit from each of the baskets. How many ways can I do it?
Here it will be 1 by 3.
There is no 1 by 3. From each of the baskets, it is 3 into 2, which is 6 ways. Okay. So the first thing that you need to understand is, when do I use the addition rule and when do I use the multiplication rule? So the addition rule is when an action, and what was the action I was talking about here? The action was you were choosing a fruit from the first basket. That is my first action. The second action is choosing a fruit from the second basket. When I am telling that you choose from A or from B, I will apply addition rule. So it is 3 plus 2, which is 5 ways to do it. However, when I am doing the same action in N1 ways, that is 3 ways, and the second is in 2 ways, the number of ways that this, both of them, so choose from 1 and 2, it is a multiplication rule of counting. So whenever your question is to A or B, it would be addition. A and B, it is going to be multiplication. Is this understanding at a conceptual level clear, please?
Yes, ma'am.
Yes,
Or means add?
yes, ma'am.
Add means
Yes,
to
ma'am.
multiply.
Yes,
That is the first thing. Now so the idea is, whenever you're presented with any question, you need to comprehend whether you have to apply the additional rule. See here, for example, here the context is the same. I have, in both the ways, I have the two baskets of fruits. In one basket, I have 3 fruits. In second basket, I have 2 fruits. But the way I posed a question, one was or and one was and. So which rule to be applied depends on how the question is being asked. So that is the first understanding. So now let's test the concept by asking another question. Now suppose I give you the following. I am asking you to, so in probability we keep seeing rolling of dice. So I have 2 dice given to you. Okay, this is dice 1 and dice 2. Okay. And I'm going to, each die has 1 to 6 written on it. Now I'm telling you the following. The first decision is you choose a die, and once you have chosen the die, roll the die. Okay. So what are you doing here? What are your 2 decisions here? First is you choose a die. Okay. So this is an action is, what is your first action here? Choosing a die. Okay. And then you're rolling the die that is chosen. Okay. So choosing a die and rolling a die that is chosen. So what are you doing? So how are you so what are the actions? The first one is choosing and second is rolling. How many ways can I do the first action? 2 ways. Second action, 6 ways. Okay. So if I am going to choose a die and roll only 1 die, what are the total possible number of outcomes? Listen to me carefully. Listen to me carefully. I am choosing 1 die. So the first action is to choose a die. die. Number of ways you choose a die. And then you only roll the die that you have chosen. Okay. You roll the die that you have chosen. So will it be 2 into 6 or will it be 2 plus 6?
2
I'm
into
not
6.
saying
2
roll
into
both the dice together. I'm not saying roll both the dice together. Listen to it very carefully. I am telling you choose a die. Okay. And then roll the die. So what are the two actions that are available here? If I want to apply my rule here, what are the two possible actions? One is action
Choose
A.
a die and
What is
roll.
the first action? First, you are choosing a die.
Yes,
And how many ways can that happen?
2 ways.
2
Two
ways.
ways.
2 ways.
The second action is rolling the die. How many ways can that happen?
1 way. 6 ways.
6
6 ways.
6 ways. Here it is. So listen to it. So now what is the total number of ways of action that I roll a die? Okay, I choose and roll. How many ways? Can it happen 6 ways or is it 8 ways?
8 ways.
12
I'm
ways.
choosing a die. Okay.
And
What is the total number of
12 ways.
Well, how? No, I'm not choosing. I'm not rolling both the dice together. No,
8
brother.
ways.
8
Right.
ways.
8 ways.
8 ways, right?
It's
I'm not rolling. See, if I say roll both of them together, then the first die has 6 possible options. The second one has, if I roll both of them together, how many ways can I do it? The second has 6. So the total number of ways total number of outcomes are what in this case? First is 6, second is 6. So I can have a 1, 2, 3, 4, 5, 6. Or for each one of them, I can have a 1, 2, 3, 4, 5, 6. So I get 36 possible outcomes if I'm rolling both of them together.
Yes, ma'am.
Yeah. But if I am doing the other way, if I choose the first, I'm just choosing the first one. Okay. And I could, no, it is not occurring simultaneously. That's why I'm very carefully telling what is the event. It is you're choosing one of the dice. Okay. And then I'm rolling it. So I could choose dice 1 or dice 2. Okay. Right.
Yes, ma'am.
And it is
Yes,
6.
yes.
So the number of ways I can, is that clear?
Yes, ma'am.
Yes, ma'am.
See, that is the reason why we are trying to have this,
Yes,
is to try and clarify some of the most commonly used confusions. Okay. Remember, permutations and combinations, the more you practice, you will get it. Okay. So the first thing is to understand what is the addition rule and multiplication rule. In addition rule, you write down what are the possible outcomes and add the total. Suppose 4 plus 3, it will be 7. Whereas in multiplication rule, it is to multiply the number of outcomes. Now, this can be extended across to many times. So this is one doing once, 2, thrice. Okay. When you roll the dice simultaneously, it is 36. Okay. So here it is dice 1 or dice 2, but the idea is also whether you're choosing dice 1 or dice 2 happens in 2 ways. Okay, that's why we have it. Okay, dice 1 and dice 2, it is simultaneously rolling 2 dice. Okay. So now this multiplication rule, we just started with having 2 events or 2 things happening simultaneously. So now we can extend the whole thing. Suppose I have 3 events happening. There are n1 ways of the first event happening. There are n2 ways of the second event happening. There are n3 ways of the third event happening. Then if I use addition rule, there are n1 plus n2 plus n3 ways of the events happening. For multiplication rule, it is n1 into n2 into n3 ways of the events happening. Is this clear? Yeah.
Yes, yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now we
Yes,
are going to look at what is the. So let's look at a few questions here. So the first one is find the number of 4-letter words with or without meaning. These are the common questions that are usually asked, which can be formed out of the letters word LOVE. Repetition of the letters is not allowed. So if repetition of letters is not allowed, I have 4 letters. How many ways can I do the first one?
24.
4 ways.
This is 4 ways. Repetition is not allowed. So the second one is 3
Three.
ways. 2, and this is 1. Now will you use a multiplication or the addition rule here?
Multiplication.
Multiplication rule.
Because it is and so this is 4 into 3 into 2 into 1. However, if the repetition was allowed, then what would it be?
4
Again,
into 4 into 4 into 4.
Power 4.
4 to the power of 4.
to 4.
To the power
Yes,
of 4.
repetition is allowed. Okay. So this is what we are trying to see is I can just apply the multiplication rule to find out these answers. Now, second thing is I have 4 flags of different colors. How many different signals can be generated if the signal requires the use of 2 flags, one below the other? 12 ways.
Yes, ma'am. 12 ways.
4 flags
12
of different
ways.
colors. How many ways? Again, am I using multiplication or am I using, what is the rule I'm using here?
Multiplication.
Yeah. It is 12 ways. Okay. Now look at the third question. How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? So I am looking at 2 digits, but I'm looking at even numbers. So in how many ways can this be fixed? The
10.
second one?
10 ways.
10 ways? No, let's look at this. This
2 ways.
can be 2 ways, but it can be either a 2 or 4. Now there are 5 ways of filling this. So 5 into 2, 10 ways. How many 2-digit odd numbers can be formed?
15 ways.
So that is 5 into 3. How many 2-digit numbers can be formed?
25
20,
ways.
25.
Will this add up? 5 into 3 plus 5 into 2? It should, right? Odd plus even 2-digit numbers. Is that clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so I think there is a request that people don't speak in between. You're unable. Are you able to hear me now? Okay.
Yes, ma'am.
You are
So
clear,
now,
ma'am.
when I have, so just as so the multiplication rule. See, I have 2-digit numbers. I have 1, 2, 3, 4, and 5. When I'm talking about even numbers, this place can be filled with either 2 or 4. So there are 2 ways of filling up this number. Now this can be filled with 1, 2, 3, 4, or 5. So this is with 5 into 2. So there are 10 ways or 10 2-digit even numbers that can be formed. Okay. Similarly, odd number, this can be either a 1, 3, or 5. So there are 3 ways to fill it. This would be 5. There would be 15 ways to do. So I'll get 15 2-digit numbers. Okay. That's how it is. Right? Okay. So now, see, today I'm not going to focus on why 0 factorial is 1 and everything, because there are too many things I have planned for today. Okay, this would require some time for me to. So just, there are certain questions which are relevant with respect to today's tutorial, which I'll definitely try and address. Okay. Now, what is n factorial? So suppose I have n blocks here, and I am trying to question 2. what is question 2? 4 flags of different colors. So let me assume red, blue, green, and yellow. Okay, and I want to use a signal which has 2 flags, one below the other. Okay, how many ways can I choose this color? It is 4 ways, right?
Four ways.
How many ways can I choose this color?
3 ways.
3 ways.
3 ways,
So
ma'am.
how many ways can I create the signal?
12 ways.
12 ways.
I'm not,
12 ways.
so here it is clear that I am not using the same color again. Okay, I require different colors, different signals. Okay, right?
Yes, ma'am.
Okay, so now suppose I have n blanks, then I can fill up this blank with n ways. Once I fill this up with n, without replacement, I do it in n minus 1. So there are 2 things we need to understand, whether I'm doing with replacement or without replacement. That is, I have n objects and n blanks, whether I'm doing it with replacement or without replacement. If I'm doing it without replacement, if I fill up the first blank, there are n possible ways. I have only n minus 1 possible ways of filling up the next blank because I've already filled up with 1 here. So how many possible ways will I have for this blank, the third blank?
N minus
N
2.
minus
N
2.
minus 2.
Minus 2.
So the first going so far, I'll have only 1 way of doing it. Suppose I'm doing it with replacement. I can do this in n ways. How many ways can I do this? I can do this also in n ways. I can do this also in n ways. I can do this also in n ways.
N power n.
So this would be n power n, and this is going to be n into n minus 1 into n minus 2 into n1. Remember, again, we are always applying now the multiplication rule of counting because we are counting and how many ways in sequential and performing all the events together. Okay. Now this n into n minus 1 up to 1 is represented by this symbol, which is called n factorial. So when we talk about a permutation is an ordered arrangement. So I could have, suppose I have n objects, I could take r objects from here. So suppose I have again n ways of doing it. I want to have, suppose I have only r blocks. This is n minus 1, this is n minus 2, this is n minus. So this is the first one, this is second is n minus 2 minus 1, this is n minus 3 minus 1. So what would be the rth way? It would be n minus r minus 1. So that is what I call n choose r. Is this clear? This is n permutation r. This is what is the symbol, which is nothing but n into n minus 1 up to n minus r plus 1. Is this clear? Now
Yes,
I can
ma'am.
write this as the following. Okay. So this is, see, whatever specific doubts you have, I would request you to please put it into the discourse. Okay. You can please put the specific doubts. You can write it to the discourse or you can write it to your instructors. We will take care of it later because I don't have the time to read the chat and answer these questions. I hope that is clear. Okay. R is the following.
What you just said, how can n minus 1 be represented as n minus 2 minus 1? What is the logic in that?
Okay, see, suppose I have 5 objects, okay, and I have 3 blanks. How many ways can I, without replacement, how many ways can I fill the first blank?
5
ways.
5 ways.
Second blank?
5 ways.
4 ways.
4
Third
ways.
blank?
3 ways.
3 ways.
Okay, now I have 2 blanks. First one, how many ways can I fill it up?
5 ways.
5
5 ways.
Yes. So this is 5, okay, n, right? This is n minus 1. Okay, the second blank can be filled in n minus 1 way, n equal to 5. The third blank can be filled in n minus 2 ways. Is this clear?
Yes, ma'am.
Yeah, okay.
Yes.
Now I have r blanks. So how many ways can I fill the first blank?
N ways.
I have r
N.
n ways. The second blank?
N minus 1.
N
minus 1.
N minus 1 way. So this is the first blank, second blank, third blank.
N
N
minus 2.
N minus 2 ways.
The fourth blank is N minus 3. The rth blank, how many ways can I fill it up?
N minus R.
minus R way.
N
N minus
R minus 1.
N minus R minus 1.
R plus.
Because this is 4 minus 3, 3 minus 2, N minus R minus 1. Is that clear?
Yeah.
This N minus
Yes,
R
ma'am.
minus 1 is nothing but N minus R plus 1.
Yes.
Yes,
Ma'am.
ma'am.
So the total number of ways I can fill up R blanks using N objects is N into N minus 1 up to this. This is the term,
Yes, ma'am.
Yes, ma'am.
right? So now I can do this as N into N minus 1. So let's go back to this example. It is 5 into 4 into 3 if I have 3 blanks. Yeah.
Yes, ma'am.
Yes, ma'am.
So I can
Yes, ma'am.
do the following here. I can multiply it with 2 into 1 and 2 into 1. I can do this, right?
Yeah.
Now this is
Yes, ma'am.
nothing but
Yes,
5
ma'am.
factorial. And this is 2 factorial,
Yes, ma'am.
right? So I can continue that. I can use the same idea here as I can multiply this with N minus R up to 1 and divide it with N minus R factorial. I can do the same thing. The same idea I can do it here, right?
Yes.
Yes, ma'am.
So would you all agree that this NPR is nothing but N factorial by N minus R factorial?
Yes,
Yes,
ma'am.
yes, ma'am.
So that is how we get this formula for NPR. And you can see if R equal to 0, since 0 factorial is 1, it is equal to 1. NP1 is N. Okay. NP1, actually, what is NP1? NP1 is the number of way of choosing one object from N objects. How many ways can I choose one object from N objects?
N
N
N ways.
Anyways.
Trivial, right? Okay. And NPN, how many ways can I choose all the N objects from N objects?
One way.
One way.
N
One way.
factorial.
Factorial.
N factorial ways, right? You can arrange. I'm choosing all the N ways. So I can either choose 1, 2, 3. I can choose 2, 1 and all of that, right? N ways. How many ways can I choose it? Arrange it. Sorry.
N
Arrange,
factorial.
not
N
choosing,
factorial.
arranging.
Yes,
Okay.
N
N
factorial.
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 So this is what we are calling the NPR, and this is with replacement, it is N to the power R. Okay, because I can do the first one in N ways, second one in N ways, third one in N ways, up to Rth one in N ways. I am multiplying it R times, so it is N to the power R. Are these things clear?
Yes, ma'am. Clear.
Yes, ma'am.
Yes, ma'am.
Yes,
Clear.
ma'am.
Right.
Yes, ma'am.
So let's look at
Yes,
some
ma'am.
problems here. So I'll just ask a few questions. Just think these are very, I think you would have done problems, but yeah, we'll do let's look at a few more and then do the problems here. So now these are again, so these were when I had distinct, all the objects were distinct. Okay, for example, I was talking that when I had all the objects were distinct, I had LOVE or we had ROSC. So you'll have problems where they'll say that how many ways you can write, you can arrange these alphabets. How many ways you can arrange these alphabets. Okay, how many, so you'll see, you'll see answers or questions of how many ways can I create a 4-digit code or a pin, right? You would have seen questions of this kind, right?
Yes, ma'am.
Password.
Yes,
So how many ways can I create a 4-digit pin where all the digits are distinct? How will you solve this using the multiplication rule?
With replacement or without replacement? Yeah, ma'am.
I said all the digits are distinct and it cannot start with a 0.
4 into
So 3 into 4 into 4 into 4.
All factorial ways.
Just remember, I want you to create a 4-digit pin.
24.
So
All factorial ways.
9 into
10 into
9 into 10 into 10 into
9 into 10 into 8 into 7.
This can take anything between 1 to 9, which is 9. Okay.
9.
Distinct. I said distinct. So how many choices do I have for the second one?
9.
9.
9. Third one?
8.
8.
8. And this would be?
7.
7.
Is it clear? Here, remember I
Yes,
said you
ma'am.
cannot start with a 0.
Yes, ma'am.
Now I'm
Yes, ma'am.
saying that, so now you can try and look at different variations of this problem. Suppose I say that you should have only an alphabet code.
Then it starts from 26
Again,
into
46.
25.
26 into 25
25,
is 24 into
25,
24.
23.
Okay, so is that so? Lot of variation. Suppose I say that you can start, you can have an alphanumeric code. So now you see how the problems, the complexity keeps increasing. The idea is the same. You all understand?
Yes, ma'am.
Yes, ma'am.
The idea is the same.
Yes, ma'am.
How we are. So if I say that, okay, many times you'll ask. So now, how do I translate this into a other question? Is suppose I say the probability question is what is the chance that you will. So why do we need to know this counting formula? Why do I need to know how many codes I can this one? So you go back to probability. In probability, suppose the experiment is to create a 4-digit code. How many ways can I do it? 4-digit PIN. How many ways can I do it? I can do it in this.
With repetition.
So these are the possible outcomes. Okay.
Yes, ma'am.
Right. So you have created a 4-digit PIN. What is the chance that you'll get it correct?
One chance.
Over
One.
that, there can be only one correct PIN, right? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am.
It is very important for us to understand this permutation and combination. See, when we had very small experiment and you like tossing a coin, then I know that there are only 2 outcomes. Rolling a die, there are only
6 out.
6 outcomes.
6
If I say
outcomes.
the minute I can enumerate it. The minute I say I'm rolling a die 4 times. How many
24
possible
outcomes.
24 out.
24 outcomes.
The first die
It's a
has
6 power
outcomes.
4.
Second die has 6
6 to power
outcomes.
4.
Third has 6. The fourth has 6. So the total number of outcomes is 6 to the power of 4.
Yes, ma'am.
Yes, ma'am.
So now I
Yes,
might want to know that in how many possible ways, and I'm saying that I'm going to. So you see, why do we need to know probability? Suppose I say that, okay, you get if you are getting all the outcomes, 4 outcomes, the same number, then you get a prize. What is the chance that you win a prize?
1 upon 6 to the power.
Is it only one out? What are the possible outcomes? So you have a 1, 1, 1, 1, 2, 2, 2,
6
2,
by
6
6
by the total.
6 to the power of 4, right? You get
Yes,
it?
Yes, ma'am.
So
Yes,
you
ma'am.
see that for you to understand or attempt probability question, you need to understand permutations very well. So don't look at it in isolation. Don't look at permutation and combination as a chapter that you can, if somebody gives you a syllabus, okay, don't say that, okay, I don't like permutation and combination. I will leave that. I will do only probability. If you don't understand permutations, if you don't understand counting, if you don't understand combinations, you will not be able to attempt questions from probability. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So
Yes,
that's
ma'am.
very important that you should understand that. So far we were looking at permutation when the objects were distinct.
Ma'am.
Suppose I give you the objects are not distinct. For example, let's look at data. Okay, here I have A and A, they are not distinct, right? The number of permutations of n objects, so 4 objects, when P of them are of one kind and the rest are distinct. So here 2 of them are of one kind and the rest are distinct.
Yes, ma'am.
Okay. So how many ways can I do this permutation? How many ways can I arrange this?
4 factorial by 2 factorial.
Okay. So now if I give you this, you're able to answer the question correctly. So the most important thing when you're attempting permutations and combinations or probability is to first try and understand the question as to what the question is asking you to do. Okay, so here, for example, I can extend this, that when P of them are of one kind, I can extend it to, okay, P1 is of one kind, P2 is of another kind, Pk is of another kind. So suppose I have statistics. How many ways can I arrange this? So what is the total number of objects here?
10.
10.
10.
10.
I have, so 10 is my N. What is my P1 is of one kind. So how many S's do I have? How many T's?
Three.
T
Three.
I have 3 S's.
T3.
T3.
2 I.
Two I.
I2.
I have 1A and I have a
C1.
1 C.
T. So how many permutations of the letters is possible? It is 10 factorial by
3
factorial.
factorial into 3
Factorial,
factorial.
2 factorial. Is that clear? Okay.
Yes, ma'am.
So you will find questions of this kind where they'll ask, for example, root. Tell me for root. ROOT. Required number of permutations.
4
In-
4
factorial.
by 2 factorial.
Factorial by 2 factorial.
Very good. Allahabad.
Nine factorial by 4
factorial
factorial into 2
by-
factorial.
2 factorial.
9
9
factorial.
factorial by 4 factorial, 2 factorial.
Okay. Right. Okay.
Yes, ma'am.
Now let me ask you this question. How many 4-digit numbers can be formed using digits 1 to 9? Okay, I'm using digits 1 to 9. Okay, repetition of digits are not allowed.
9 factorial.
9 into 8
9
into 7
9
factorial.
into 8 into 7
9
into
into 8 into
6,
7
5,
into
4,
6.
3, 2, 1.
Very good. Okay, that's good. Okay, right. Institute. Again, how many ways can I? Institute. This is just trying it out, revising the concept.
9 factorial by 3
9
factorial
factorial by 2
into 2
factorial,
factorial.
3 factorial.
3 factorial.
Okay, very good. Just a second, please. Okay, right. So this was about the permutation formula. Okay. Now the next thing is, yeah, I'm coming to the circular table. See, when I am doing a revision, I don't go into the most complicated immediately. Okay, we'll go to, my job is to try and address the questions of the general students. Okay, right. So now in the circular permutation, the whole idea is to look at this. See, in a circular permutation, the idea is first we looked at a linear permutation, right? A, B, C, D, how many ways I can arrange this. Now, if you look at this, you try and put them as a loop, you can see that this A, B, C, D, there are n distinct objects which can be arranged in a circle. You can see that this A, B, C, D, the way they can be arranged is A. So I fix A, then I can have a B, C, D, I can have a C, D, B, I can have a B, D, B, C, and this is the way. So the number of ways I can arrange n distinct objects in a circle where clockwise and anti-clockwise are different is n minus 1 factorial. Because I'm not considering this A, B, C, D to be the same as A, B, C, D. I'm considering them to be different. Is it clear? So the way I can think about it is you fix one of them, I fix A, and the remaining can be arranged in n minus 1 factorial ways. And here the clockwise and anti-clockwise are different. So the total number of ways n distinct objects can be arranged in a circle is n minus 1 factorial. Is it clear?
The rest
Yes,
the remaining
yes,
three
ma'am.
Yes,
letters.
ma'am.
Pardon?
One example, ma'am.
Chat box? I didn't get the question, please. When roll is to be formed, then can we fill the first position with 0? Roll number. Is that what you're asking, Rishabh?
Yes, ma'am.
Roll number typically you don't allow. See, typically you don't allow 0 to be the first position unless it is specified. Okay. So sometimes the questions might say that, okay, you allow 0 also to be in the first position. Okay. So, but typically, okay, you don't allow 0 in the first position.
Ma'am, if nothing is mentioned, then what we assume, like what they are trying to say, if nothing is mentioned about 0.
See, again, this is I wouldn't consider 0 to be in the first position if I'm asking for a number. Okay. Typically, unless, but one thing you can argue is, for example, many things like a bank account starts with a 0 many times, right?
Yeah, ma'am.
Okay. So it is again, I would expect that the question has that mentioned.
So, ma'am, there is one thing is wrong in the graded assignment of week 5, ma'am. In the question number.
Okay, if there are any questions, you please send an email to the discourse people and they can take care of it.
Okay, ma'am, sure.
May I request people not to annotate on the board this one, please? Annotation is you writing on the board. If you do not know what is annotation, annotation is I can see people are writing it here. Okay. Okay. So for
Good
people
evening,
who
ma'am.
are-
Excuse
let
me.
me explain the circular permutation. See, what I'm trying to say is, if I had A, B, C, D alone, right? Okay. How many ways can I arrange A, B, C, D? 4 objects, 4 distinct objects.
4 factorial ways.
4 factorial ways. Is that clear? Yeah.
Yes, ma'am.
Yes, ma'am.
If I'm looking at circular combination, let me fix A. Okay. How many ways? If I fix A, I can arrange it as B, C, D. How many ways can I arrange the remaining 3?
3
3
factorial ways.
factorial.
6 ways.
Yes, ma'am.
Yes, ma'am.
Okay. So these are the possible circular, this one. Now the question is, why am I fixing A and not B? You can look at, you can turn this way. What would happen to this? This will just become BADC. Is that
Yes,
right?
ma'am.
If I
Yes,
just
ma'am.
rotate it, now it is the same permutation, the arrangement. Yes,
Yes,
or no?
ma'am.
Yes, ma'am.
Whether I'm fixing A or B is not making a big difference here. Similarly, if I rotate it again, it's going to be C, B, A, D. All of them are same.
Yes, ma'am.
So we are looking
Yes,
at
ma'am.
distinct arrangements. So is this clear as to why it is n-1 factorial?
Yes, ma'am.
Yes,
Clear.
ma'am.
Yes, ma'am.
I just fixed A as a particular thing. Okay, nothing more than that. Yeah, right. So now
Yes, ma'am.
suppose we are looking at the following here. See, as I mentioned, all these specific questions you can write and I'll try and answer it, but it takes some time. I have a lot more to complete. So please, if you have a specific question, you post it prior to a session so that we can take it up during the session. This is a good practice. I'm just telling all of you, a good practice is if you have specific questions, you please send those questions prior to an announced session.
Hello, ma'am. Prasant.
Yeah.
Prashant this side, ma'am. Yeah. So
Yeah, Prashant.
yeah. So hello everyone. So don't ask questions related to PA or GS something else. If you have query related to it, you can ask in other session which we are conducting. Okay. So let's finish the concepts by ma'am.
Yeah,
So
so the
please
idea
cooperate. Yeah.
of this is to
Yeah.
just highlight on the conceptual understanding, okay, not to do a lot of problems. It is not a problem solving session. Okay, I'm not saying that I will not answer these questions, but I'm just trying to focus on the concepts more here. Is it okay? Is that clear? Yeah.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So when
Yes,
you are,
ma'am.
so whenever you are asked questions, first of all, you need to, so now again, there are a lot of questions in permutations where they'll say that the following is, for example, find out the number of ways I can seed. 1 second, let me go. Sorry, yeah. So now, okay, I have a question here with me which says that you look at this is not a circular permutation, but this is again to answer a question earlier. Is suppose I am asking that how many ways can 5 men and 3 women sit together if all the women insist on sitting with each other all the time. You have questions of this kind, right? So I know that 5 men and 3 women, all the 3 women are sitting with each other together. Then after 6 ways, I can talk about it as 6 distinct objects. And how many ways can I arrange 6 distinct objects?
6 factorial.
6 factorial ways.
Factorial
6
ways. But
factorial.
these 3 women are also distinct. So how many ways can I arrange them?
3 factorial.
3 factorial ways.
Factorial.
So how many ways can I do it together? It is 6 factorial into
6 factorial into 3 factorial.
Okay, right. Now, how many ways can I arrange the 8 people? Now, there are 8 people distinct. How many ways can I do that arrangement?
8 factorial.
8 factorial.
8
8 factorial ways. So now, suppose the question is tweaked in this way that such that no woman sits together.
All combinations minus all women sitting together.
So this is how you are going. So the first step is, see what we are, see the first thing, I have 5, anything. So you'll have problems also of the kind where I have 5 white balls and 3 blue balls or something. I want to create, or 5 white beads and 3 blue beads. Okay, right? And I want to try and put them in a string. How many ways can I put them in a string? Is this the same as men and women? What is the difference here?
5 factorial into 3 factorial.
That's it.
Ma'am,
Think
here
about it.
anti-clockwise and clockwise
these
doesn't
are
matter.
Here
beads.
the white and the blue balls, it makes no difference.
This is beads. So what do you? So what is it? Men and women are different from beads, right?
Yeah.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So
We'll
now,
divide by 2.
so do you? So first of all, 5 white beads and 3 blue beads or whatever it is. How many ways can I arrange them?
8 factorial.
8
Factorial.
8 factorial ways. And
Divided by 5 factorial.
5 factorial.
It's
So
actually 8
we are
factorial.
going to apply this, right? Is this clear?
Yes, ma'am.
Whereas when I'm
Yes,
saying 5 men, see, I have a request to make. Please, can you all stop annotating on the board? You see, I have people who are making these things.
Ma'am, there is an option available to me. Can I erase them?
You can erase it, but why? Why are people doing this in the first place? Can't I expect this level of the discipline?
No, ma'am, I can't erase them.
No, I
Only,
have erased them, don't worry.
okay.
Ma'am, there is an option to disable animation.
That option.
This is not acceptable. That's what I'm trying to say. That's it. Nothing more than that.
Ma'am, restrict annotation from your side.
Why should I do that? Ask me why should I do that? I'm just asking, can't I expect this level of discipline from a student, IIT student?
Yes, ma'am. You can.
Yeah. Is it too much to expect?
No, ma'am.
Okay. I don't want to say, I respect you all. I appreciate that all of you have come here, okay, on a Saturday night to learn data analysis. But I think this is very important that there is some discipline that is maintained. I don't want to pick up on people, but I'm sure the people who are doing it can show some more maturity and not do what they're doing. Okay. Thank you. So you see that when I talked about 5 men and 3 women and I wanted to arrange them in a line, okay, with 3 women together, we said that it was 6 factorial into 3 factorial. All of us understood till this?
Yes, ma'am.
But the same
Yes,
thing
ma'am.
when I say 5 white beads and 3 blue beads, I want to arrange in a necklace. I'm not telling again circular necklace. Okay. How many ways can I do this?
8 factorial by 5 factorial.
Factorial by 3 factorial. But now if I want these 3 blue beads always together,
3 factorial into 5 factorial.
is it 3 factorial?
6 factorial by 5
6
factorial.
factorial into 5 factorial.
6 factorial into
Have these
factorial.
3 beads together, the 5 beads and this would be always together. So how would I do it?
6
6
factorial.
factorial
into
into
5
3.
factorial.
6 factorial divided by 5 factorial. And these 3 beads, would it make a difference whether how many ways can I do that, or
No, ma'am.
Just one way.
it is just all the 3 are one. That's only one way, right?
Yes, ma'am.
Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Absolutely.
Yes, ma'am.
Yes, ma'am.
Right. Okay, that's good. Is this clear? So you need to understand whether it is distinct objects or whether it is the same thing, whether I'm talking, just because I ask 5 men and 3 women and you know to do it, you cannot apply the same thing to 5 beads, or you cannot, I ask colored balls, I'm putting colored balls in a line. I cannot do that, right? Now, yes. Now I'm asking the second thing. I am seating these people in a circle. 5 men and 3 women in a circle. How many ways can I do it?
Can you explain the by 5 factorial again? 6 factorial by 5 factorial.
Okay. See, this is, suppose I am putting all the 3 beads together. The 3 black beads have to come together.
So we have total 6 objects to arrange. We can
Right.
consider it as the 6 objects to arrange.
Right.
And then what is the 5 factorial for?
Okay, just tell me how many ways can I arrange 5? Okay, let's start from beginning. 5 white beads and 3 black beads. Okay, I am having these, and how many ways can I arrange all these 8 together?
6
Linearly.
factorial.
Linearly, I have 8 beads.
8.
How many ways can I arrange them?
8
I have
factorial.
8
factorial.
beads.
Factorial by 5
Eight
factorial.
beads, where 5 are of one kind and 3 are of other kind. How many ways can I do it?
8
8
factorial upon
factorial
5
by 5
factorial.
factorial into 5 factorial.
Just a minute. Let the person who asked the question answer it, because I'm addressing that doubt. Yeah, 8 factorial by
3 factorial into 5 factorial.
Is this clear?
Yes, ma'am.
This is clear. Now I am telling that the 3 blue beads are always together. So how can I look at this entire thing?
We can look at it as 6 distinct objects now we need to arrange.
6 distinct objects where 5 are of one kind.
Yes, yes, ma'am.
So how many ways can I do the arrangement?
6 factorial, and because 5 beads are of the same kind, we have to divide it by 5 factorial.
That's what I've written here, right?
Yes, ma'am.
Is it clear?
We are
But I
not
think
considering
everything
5
is linear
factorial into 3
arrangement.
factorial because the 3 beads are one unit. We are
Yeah.
not considering.
Yeah, they're together, right?
Yes, ma'am. Okay. Okay, ma'am. Thank you.
So, ma'am, if anything is together, we consider it as one unit, right?
It is beads. But
Yeah,
when
ma'am.
it's women, will it be the same?
Yeah, ma'am. When it is man, and it will be the same.
No, when it is 5 men and 3 women, will it be the same?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am, it won't be the
Women
same.
can be arranged among themselves in different 3 factorial ways, right?
Because they are different women. Yeah, exactly.
Is that clear?
Yes, ma'am.
Yes, ma'am.
So when I'm talking about beads, it is the same. But when I'm talking about women, the women can be arranged among themselves in 3 different ways. So that's why I had 6 factorial into 3 factorial. Did you understand that?
Yes, ma'am.
Yes,
Got it?
ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. So that is what we need. Now, what would happen if I'm arranging 5 men and 3 women in a circular fashion? Just start from the first thing. 5 men, 3 women are sitting on a circular table. How many ways can I arrange them?
7 factorial.
7
8 minus 1, 7 factorial way. I'm not bothered about. So here it is 7 factorial provided my clockwise and anti-clockwise are, that is what it says, right?
Different.
Yes, ma'am.
Go back to your this one. Clockwise and anti-clockwise are different. When I have people sitting clockwise and anti-clockwise, right? They are different.
Yes, ma'am.
Yes, ma'am.
7 factorial. Now the 3 women want to sit together.
5 factorial.
5 factorial.
6 factorial divided by 6 factorial.
6
5
minus
factorial.
1 factorial, ma'am.
6 minus 1 factorial, or how would we get it? The 3 women want
5
to sit together.
factorial into 3 factorial.
Into 3 factorial.
It is
5 factorial into 3 factorial.
5 factorial into 3 factorial.
6 factorial into 3 factorial.
Why?
Because, ma'am, 3 women's can also arrange between them.
Yeah, I will, among them, they can arrange themselves, right? I consider this as one unit. Here they can arrange themselves, and the other people I'm considering as the 5 men. So this would be 1, 2, 3, 4, 5, 6. So 5 factorial into 3 factorial. Now when I'm doing the beads thing, what would happen?
Then, ma'am, then will we
No
give-
arrangement, only
No
5
arrangement
factorial.
within the
It will be only 5 factorial. Yeah.
It will be 5 factorial.
No.
No,
what are
ma'am.
the numbers?
N
Can I
ways, ma'am.
repeat?
It is
Only
always
one
same.
way.
How many ways can I arrange it in a necklace form?
In a
Ma'am,
one
only
way,
one
ma'am.
way.
How many beads are there exactly? Sorry, I forgot the number.
5 white and 3 blue beads. In a
I mean,
necklace form.
So
3
eight-
blue beads
so
are
eight-
together,
Three
then
blue
one way.
beads are together always.
So 8 factorial
Only 6
divided
ways.
by 5 factorial.
Use your common sense.
Because
first.
clockwise and anti-clockwise, it makes no difference.
Ma'am,
See, first, I'm having the blue beads together and the white beads and the white beads.
6 factorial divided by 5 factorial.
What is 6 factorial?
5 factorial divided by 2. 5 factorial
I
divided
have
by
5
2.
white beads
One
and
way.
3 blue beads. I'm putting them in a necklace form. Okay, how many ways can I do it?
2
Ma'am,
factorial,
6
One
factorial
way.
by 5
2
factorial.
ways,
Ma'am, 8 factorial by
Only
2.
one way.
just 2 ways.
5 factorial times 3 factorial by 2.
Just want you all to think
One way
about
only.
it. Okay, I just want you all to
7
think about it.
factorial
See,
by
this is
2
the problem when you try to apply formula. Okay, I
It
have
will be
5
divided by
white
2.
beads. 4, 5, and these 3 beads are together. So how many ways can I put it as a necklace?
If clockwise and anti-clockwise are same, it
I'm
will
only
be
one
just
way.
Everything is same here, right? Clockwise and anti-clockwise are
one.
the same here.
Then one
right?
way.
There's only one way, right?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
We are saying one way only.
Okay. So the thing is, what you have is always, there is an anxiety to jump into a formula and apply a formula. Okay. So think about, especially when you see a question on probability or on counting or something, try and understand what is the question being asked. Okay. That would help you. No, I didn't talk about men and women. I talked about beads. When the 5 men, that's why I'm considering the 5 men and 8 women. men and women, we already solved the problem. When it is beads, everything is of the same kind. Okay. And I want the 3 beads to be the same. Then after such, it is going to be one way of arrangement. I cannot make too many necklaces that way, right? Okay, yeah. Women, it will be 3 factorial. 5 plus 1, 6. 6 minus 1. See, beads, what I'm trying to say is when I have 5 beads and 3 black beads, the 3 black beads blue beads are together and 5 white beads are together. How many ways can I do as a necklace?
One way.
Yes,
One
one
way.
way.
Only one way.
Right?
One way.
And that you can apply the formula. I just leave it as an exercise for you to apply the formula and see that. Okay. Yeah.
Okay, ma'am.
The idea is you need to understand what is the context of the question and how am I applying it. Now the next thing is when the order is not important at all, or when
Excuse me, ma'am.
Yeah.
Good evening, ma'am. May I ask a question? May
Yeah.
I ask a question on the concepts of circular permutation?
Yes, please.
Whenever we are arranging objects into concentric circles, why do we initially consider n minus 1 factorial and then the remaining, like from the remaining, we don't subtract 1? Like if you could explain that case once.
In concentric circles?
Yes, suppose 6 children have to be arranged in 2 concentric circles.
Okay.
A question like that. So, ma'am, how can we arrange it? Suppose one girl is compulsorily sitting in the inner circle.
Okay.
So, how can we arrange it?
There is one girl compulsorily sitting here. There are 6 children. 6 children, do I have any? So C1, C2 up to C6 with one person compulsorily in this.
Yes, yes, ma'am.
Okay. So what is the question here? How many ways?
How can we, yes, how can we arrange them in 2 concentric circles?
Okay, so I can, one person, at least one here or only one here?
At least one here.
At least one here. So
Yes,
then
ma'am.
it is again a concept of counting here. So if there is only one here, I'll have 5 people here. How many ways can I choose this one person here? If from the 6 people?
6 ways.
6 ways. Now that I have chosen the one person here, how many people do I have to choose from here for their outer circle? 5 ways, right? 5,
Yes.
5
Yes,
ways.
ma'am.
And how many ways can I arrange those 5 people?
5 factorial ways.
5
5 minus 1
Factorial.
factorial ways.
6 minus 1 factorial, 4
Okay.
ways,
Yes, ma'am.
right? Now then you go and see how many ways I can choose 2 people here.
6C2.
6C2 ways.
So this is 6C2 ways, right? We have
Yes,
not
ma'am.
come to a combination, but 6C2 ways. How many ways can I arrange these 2 people here? It is only one way. Okay. The remaining I can choose in 4C. The remaining 4 I can put it in 3 factorial ways. Got
Yes,
it?
ma'am. Yes,
Then
ma'am. Yes,
3
ma'am.
people here.
Yes, ma'am.
Okay.
I've got the concept. Thank you,
Got
ma'am.
it? Yeah.
Yes, ma'am.
Okay, so that
Yes,
is
ma'am.
how you can get it. So it is just a basic law of, again, counting. You start looking at permutations and combinations and counting how many ways you are doing things. Is that clear?
Yes, ma'am.
Ma'am, I have a doubt.
Yes, ma'am.
Yeah.
Ma'am, in the circular permutation, we are taking n minus 1 factorial because we fix one object as
See,
we
that one object only I said doesn't matter. See, for example, if I go back here, okay, I said that here I fixed A. Okay. If I fix this A, I get with the remaining, these are the types I have got, which is 6, total 6, because it is 3 factorial. Is this clear? So do you accept with me it is 6 ways of doing it? Why only A? Because suppose I fix B instead of A. Okay. You see that this arrangement of A, B, C, D is the same as this arrangement, right?
yes, ma'am.
So whether I'm fixing A or B or C or D does not matter. I'm going to get only 6, that is 4 minus 1, 3 factorial ways of doing it.
Okay, ma'am. Clear. Thank you.
Is that clear?
Ma'am?
Ma'am, when we have to, for the concentric circle problem, when we're choosing 2 children from 6, do we have to use permutation or combination? Because
See, whenever you're choosing 2 people, okay, the order does not matter. You're using a combination. So we are not come to combination. So the combination is whenever, suppose I'm telling you the following. Let's look at it. I have a class of 40 people. Okay. I have a class of 40 people. And in these 40 people, one second. Are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yes,
Visible.
ma'am.
I have a class of 40 people. And from these 40 people, I want to choose 2 people. Right? Okay. Now here, I'm just choosing 2 people. I'm not bothered about whether I'm choosing. I'm just choosing. The arrangement does not matter to me. I'm just taking 2 people from 40 people. Now, if I'm asking the question that from the same 40 people, I am choosing a head boy and I'm choosing a, say, president, and I'm choosing a vice president. What is the difference in these 2 statements?
Positional difference, ma'am.
Order
Order
In
matters.
which the order matters and which order does not matter.
I mean,
are-
choosing order
choosing-
does not matter.
while
But
choosing
choosing the
president-
position
Two
order
people
matters.
even
The
in the second
president and
case,
vice
but I'm
president.
choosing a president and a vice president.
Then order matters.
Order matters.
Order
sir.
matters.
Right?
Yes,
Because,
ma'am.
see, I could choose the way I'm choosing 2 people, whether I'm choosing Ram and Shyam. Okay. Whether I'm choosing Shyam and Ram or Ram and Shyam, I'm just choosing 2 people. There the matter doesn't matter. But if I'm choosing Ram as president and Shyam as vice president, or Shyam as president and Ram as vice president, it is different. Would you agree with me?
Yes, ma'am.
Yes, ma'am.
yes,
In
ma'am.
one case, the order matters, and in one case, the order does not matter. Is that clear?
Yeah.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Ma'am.
ma'am.
I have a doubt in it.
Order matters. So we will be looking at a lot of questions where we'll have to tell whether so now let me tell you, suppose you are choosing, you have a group of 5 people and you want to choose 3 to form a committee with specific roles: president, vice president, and treasurer. Are you going to use a permutation or a combination?
Permutation.
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 Yeah. Order matters here. Now, suppose I'm telling the same thing that you are choosing 3 people to form a committee. What is what
5
are you
3 combination.
Combination.
for a committee? I'm using combination. I'm not using permutation. Is this clear now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Right? Okay. Now let me look at a few more questions. You are forming
There is
a
doubt
team.
in-
Okay.
Basically, their
You're
events are
forming a team of 11 players to participate from a pool of 60 players. You're forming a team of 11 players. Are you using permutation or are you using combination?
Combination.
Combination.
Using a team of 11 players where I specify who is the opening batsman, who is the one down, and who are the bowlers, then am I using permutation or combination there?
Permutation.
Permutation.
So when I have specific roles, then I'm going to always use permutation.
Permutation.
When
the order does not matter, it would be combination. Is that clear?
Yes, ma'am.
I'm just going to skip over this. Okay. So now choosing okay. Now let's look at it. Forming or choosing a team. So if team member roles or positions are distinct, you'll always use present permutation. So you'll have variations of these questions. They'll say team leader, presenter, coordinator, or this one. Selecting president, vice president, and treasurer from 100 people, permutation or combination?
Permutation.
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 3-member team from group of 10 to attend a conference.
Combination.
From group of 8 to participate in a tournament.
Combination.
Combination. Selecting the 3 top players from a group of 3.
Permutation.
Permutation.
Because here ranking matters, right?
Yes.
We have a 3 factorial.
Second, I'm not choosing just 3. Is that clear?
Yes, ma'am.
Yes, ma'am.
4-letter code. Again, I think we have done this.
Permutation.
So now you can see that the sample space. So now is the permutation and combination part clear a bit?
Yes, ma'am.
Ma'am.
Let's do a few more. Arranging students in a line for a race.
Combination.
Arranging students in a line for a race.
Permutation.
Right. Okay. Now let me look at a few more examples. Okay. I think no probability class would be complete without a card question. Picking 5 cards from a standard deck of 52 cards.
Combination.
Selecting 2 books from a shelf of 5 books.
Combination.
Combination.
Combination. Arranging 2 books from a shelf of
Permutation.
Selecting 2 marbles from a bag of 5 marbles.
Combination.
Okay, this is a nice one. Choosing ice cream toppings.
Combination.
Forming a password with
Permutation.
So now this is selecting winners in a contest.
Permutation.
Ranking and order is important. Okay. Forming a relay team.
Combination.
Permutation because the strength.
Permutation.
Relay team, there's an order, right? Who runs?
Yes,
There's
ma'am.
an order.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
What will it be? It would be a permutation.
Permutation.
Ma'am, why is ice cream flavor combination?
Ice cream, you're just choosing 3 flavors.
Why any arrangement doesn't matter. Okay, ma'am.
If arrangement matters, suppose you want to know, I'm just telling 3 flavors. Oh, but if you are specific that chocolate should be on top of vanilla and on top of strawberry, and that way, then after it would be a permutation. But do you actually do that in an ice cream? I do not know. Okay.
No, ma'am.
Yeah. Is that clear, please?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is the basic thing about permutation and combination. I will just move over to the probability review now. Okay. So the idea in permutation and combination, I'll just do this is you need to understand. So why do I need permutation and combination? Because when I am talking about probability, I define a random experiment, I define a sample space, and I need to know, because for example, if I'm looking at all permutations of A, B, C, D here, I don't have to enumerate all of it. If I know that what is the total number of outcomes in my sample experiment, I can find the probability. Is it clear? What is the chance of forming the code A, B, C, D? It is 1 by 24. What is the chance of you cracking it? It can be about 1 by 24. Okay.
Yes.
Yeah. Right. So I'm just going over to the probability part.
Ma'am, can you just explain what events will happen simultaneously and what will not, ma'am?
I'm not sure I understood the question. What do you mean by simultaneously and not simultaneously?
Yes, ma'am, because in graded assignment 6 and week 5, we had that programming assignment where we were given options and we had to choose events are simultaneous and not. In some cases, it didn't seem to hold properly. So I thought, like, for
One
example,
second, I think I need a context for it. Prashant, can you just tell me what it is about?
Ma'am, I think he's talking about EMQ. So I think Narayan, you
yes.
can ask these kind of things in instructions. I mean, session which are conducted by us. That's ma'am to revise the concept. Okay.
So see, let me tell you, for example, what is happening is here is I'm not able to relate immediately to the question that is being asked in a particular assignment. Okay. So if there is a specific question, okay, I need to understand what is the context in which the question is being asked. I hope you understand it. Okay.
Right. Yes, ma'am.
I'm not discouraging you from asking the question, but if there are specific questions, my suggestion is whenever a session is announced, I would request you to place the specific question before the session so that you get the answer to that question. Is that clear? Because
Yes.
for me to relate to that question is not very easy for me to do it immediately because I don't have access to that question. Is that clear? Immediate
Yes, ma'am. I'll do that from now. Yes.
Yeah.
Okay.
Okay.
Ma'am, just want to say something about the question to be asked in the
I can't hear you very clearly. Yeah.
They do provide answers whenever they can, but sometimes it's too late, ma'am. You know, but the graded assignments are done by the time you get the answers. So sometimes it's very difficult to keep pace with asking questions and getting to know the answers. So if you could please touch upon that particular column I mentioned about the 10 rooms. And
Okay, I will talk to my team and I will find out what is the problem. Okay. Thank you for bringing it to my notice. I'll just talk to my team and find out whether we can speeden it up. Is that okay? Yeah.
Yes, ma'am. Thank you.
Thank you. Thank you for bringing it to my notice. I will talk to my team and I'll figure out what is the issue. And if there's an issue, I'll definitely I will look into it. Okay. Yeah.
Ma'am, for the blue and white beads questions, for the number of permutations to be 1, does it require to be mentioned that the white beads have to be in the center of the blue beads or something? Because otherwise,
when it is in the center in a necklace, do you think it should happen? You answer the question. When I'm talking about it in a necklace form, do you think it should happen?
Yes, ma'am.
No, why? Why should it be at the center? I'm having white beads and blue beads. Would it make this one? What is the center here in the necklace?
I mean, exactly in the center of both chains of blue beads, the white beads should be there or something. Because otherwise, can we not arrange it in more than one ways? Suppose in one case we take a blue bead and then 5 white beads, and then the rest of the blue beads. Can't we do it like that?
No. Wherever you're putting those 3 black beads, the other things are going to be only white, right? In a circle.
Yes, ma'am.
The blue beads are always together, right?
Yes, blue beads are
The
together.
white beads will also be together, right?
Okay.
No, ma'am.
Okay,
ma'am, one thing. If blue beads are together, there are 3 blue beads, right? So there are 5 white beads. So we can arrange it like this, like 2 white beads and then 3 blue beads together and then 3 white beads.
Yes,
then in
ma'am,
that
that's what
condition
I'm
also
saying.
those.
It's a necklace, right? It's in a circle.
Yeah, it is in a circle. But let's.
Then where will all the white beads also will be together, right?
It is also the condition, right? Both are the conditions, or only the condition is blue or together.
Whether it is blue or white, okay. Would it make a difference? That's what I'm trying to say. I'm not. See, the white beads are together. I'm not talking about whether we are having a hook or anything in between. I'm just putting them in a circle.
Yeah, ma'am. So no, it is exactly the concept is like what I'm trying to ask is let's say with the condition only we want to satisfy is 3 blue beads are together, right?
See, when they are in a circle, in this case, the white beads also will be together, right? In a circle.
But ma'am,
Ma'am,
how
ma'am,
we can
ma'am,
jump to that conclusion? Like, how did we jump to that?
Together in a circle. If the blue beads are together, won't the white beads also to be
And
together?
no,
suppose
ma'am, ma'am,
suppose if we put in
they can also
Okay,
be
yeah, yeah,
arranged
yeah.
put in
Okay,
as
I
two
get it.
white
Okay, okay.
beads
alternatively.
together.
Yeah,
Ma'am,
ma'am,
in
in a
starting,
circle.
we
Okay,
can
I get
add
it.
In a
two beads.
circle. In
Yeah,
a
ma'am,
straight
okay.
line, I agree. But if it is in a circle,
Yeah, ma'am. Yeah, I get it. I get it.
okay, just think about it.
Okay, ma'am.
Ma'am, then in other situations, why do we divide only by 5 factorial and not 5 factorial into 3 factorial? Why is it 6 factorial by 5 factorial instead
See,
of
when
6
it was
factorial?
a men and women, we did 5 factorial by 3 into 3 factorial. But in beads case, it is not the case, right? In the beads
Because
case,
the 3 beads that are put together can also be arranged in 3 factorial ways. It can be bead 1, bead 2, bead 3,
and
no?
they be arranged, they are of the same type. So it's a 3 factorial ways. It's
Okay,
just
then
one
ma'am,
way,
why
right?
do we do 5 factorial ways? Because the white beads are also the same. Why 6 factorial by 5 factorial?
Pardon? Yeah, it was divided by 5 factorial, right?
Ma'am, but white beads are also of the same type. So why do we need to consider
That's
5
why
factorial?
we did 6 factorial by 5 factorial. That is what we did.
But why, ma'am? But white beads are of the same type.
Yeah, that's why if I go back to this, let me show you you apply this form. 1 second. Just give me a minute. So, are you able to see the PDF?
Yes, ma'am.
Yes, ma'am.
Okay. So here, the number of permutations of n objects. I have 5 white beads and I have 3 blue beads. Okay. I am arranging them in a line. Now, what is this n here?
8.
8.
Okay. 5 of one kind, white, and
Yes,
3 of
3
blue
of
kind.
one kind.
How many ways can I arrange it? It is 8 factorial by 5 factorial, 3 factorial. Is that clear? That is the first question we asked, right? How many ways I can arrange the 8 beads where I have 5 of white and 3 of blue. Till here, is it clear?
Yes, ma'am.
Right. Now I'm saying that the 3 blue are always together. So I can look at these n objects. So how many n distinct objects do I have?
6.
6. So this would be 6 factorial by 5 factorial. Is that clear?
Yes, ma'am.
Because
Yes,
the
ma'am.
3 beads are of the same kind. It doesn't they have only one arrangement among themselves. Because I have 3 objects where all the 3 are of the same kind. Agreed?
Yes, ma'am.
Yes, ma'am.
Got it? But when there are women, if it is 5 men and 3 women, then how many ways can I arrange 5 men and 3 women if the 3 women are together always? It would be 6 factorial divided by 6 factorial into
Multiplied by 3 factorial.
multiplied by 3 factorial. Not divided, it is multiplied by 3 factorial. Do you get it? Is this clear?
Yes, ma'am.
Yes, ma'am.
It's just application of this formula. Yeah. So far, so good? Yeah.
Yes, ma'am.
Okay. So now I'm just going to give a refresher at a conceptual level again on probability. Now, whenever you are asked a probability question, the question would be as how do you find out the probability of a particular event? Okay. So I need to understand what is the event. For example, let's go back to this and look at this problem that is being asked here, where the problem is what is the probability of forming the code ABCD? Okay. So what is the random experiment here? I am actually arranging this 4 letters ABCD in different ways. Is that clear?
Yes,
That's
ma'am.
the random experiment.
Yes, ma'am.
Okay, right. So this is the sample space will have all the possible permutations of this ABCD.
Yes, ma'am.
Yes, ma'am.
Right. So then this all the permutations of this ABCD would form a sample space, and I know that the number of permutations of ABCD is going to be 4 factorial. So what is the probability of forming the code? It is
1
going
upon
to be
1 by 4
only
factorial.
1
by 4 factorial.
only one of that is going to be right. So it is going to be 1 over 4 factorial, which is going to be 1 by 24. Okay. So when we are looking at the thing, it is very essential for us to understand what is a sample space. Okay. So I am going to now, we are going to look at the probability, and we are going to just try and answer a few questions on this probability. So I'm just going to again orally ask these questions, and we'll see how we are going to look at that. Okay. So let me start. If I toss a coin twice, okay, let me toss a coin twice. I want you all to first tell me what is the sample space of this random experiment.
H, H, T, T, H, T, T,
H.
I roll a die twice. I roll a dice twice.
Heads, tails.
36.
36, ma'am.
36 sample.
Okay. Rice.
216.
216.
I toss a coin once and I roll a die once. And
12.
12.
12.
12, ma'am.
12.
What are the possible outcomes?
1 with head, 2 with head, 3 with head, till 6 with head.
Okay, so that is, so now you all know how to count it. Okay, right? So there are 12 possible outcomes, and these outcomes form the sample space. Now, given the outcomes, we need to define the events. Now, in this, suppose the event, I define an event to be the head appears in my first toss. So how many outcomes are there in this event?
2.
Tossing a
2.
coin once, and I am rolling a die.
Okay, 6.
So how many
6
heads in the
outcomes.
first toss? So how many outcomes are there? 6. H1, H2 up to H6. Okay. Right.
Yes, ma'am.
Similarly, tail in the first toss is I get a tail in my toss is it's also 6 outcomes. Okay. Now I'm telling that what is the probability of me getting a head and an even number in my toss, in my dice?
3.
3.
Because it is a H2, H4, H6. Okay. Suppose I ask what is the probability of me getting a head or an even number. So again, we need to know what are the events getting a head. What is the probability of me getting a head?
3.
1 by 2.
12,
1 by 2.
which is
1 by 2.
Probability of me getting an even number?
1 by 2. 1 by 2.
1 by 2.
1 by 2.
Because it is 2, 4, 6. I have 6 probabilities. Okay. Again, 1 by 2. Right? Okay.
Yes, ma'am.
What is the probability of me getting a head or an even number?
1 by 4.
1 by 2 plus 1 by 2.
1 by 6.
I'm
M1.
saying,
1
so
by
I
2
need to
multiplied.
understand whether they are mutually exclusive. Is getting a head and an even number possible?
Yes.
Yes,
Yes,
ma'am.
Yes, ma'am.
A head or an even number. So what is this additional probability? Additional rule of probability?
P of A union B is equal to P of A plus P of B minus P A intersection B.
So what is the probability of that? So this is what I'm calling, right? P of, if they are disjoint, I'm saying probability of E1 union E2 equal to P of E1 plus P of E2, right? Or P of A plus P of B. When they're not disjoint, what do I get?
Minus
Minus P
P
intersection.
of A plus P of B minus P of A intersection P of B.
What is P of A intersection P of B here? Probability of getting a head and an even number.
Even number.
Yeah, and
That is also half.
Is that clear?
yes.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Relating whatever we are telling to events. Okay, so I need to understand what is my even here? Probability of getting a head. E2 is probability of getting a even number. Are they mutually exclusive events? Or can I get a
No.
head and an even number?
No, disjoint
Yes,
events.
ma'am, we can get.
No. Are they disjoint? They're not disjoint, right? Because H1, H2, the outcomes are H, head and 1, head and 2, head and 3. Those are my outcomes, right? So I can get a head
Yes, ma'am.
and an even number, right?
Yes, ma'am.
Yes, ma'am.
Okay, so they are not disjoint. One word of caution is never get confused between a disjoint event and independent events. Okay. Tossing a coin, what are the possible outcomes of tossing a coin?
Two outcomes. Head or tail.
HTTH.
HT,
TH.
Just tossing a coin once, it is head
H and T.
or
H and T.
Head or tail.
Okay. Are they mutually exclusive outcomes?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Get a
ma'am.
head, I cannot get a tail. So
Yes,
they are
ma'am.
mutually exclusive outcomes. Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
We cannot have head or even. No, I'm saying even is the probability of you getting a outcome as a head. Okay. So what are the possible outcomes where you have a head? It is H1, H2, H3, H4, H5, H6, right?
Yes, ma'am. Yes,
What
ma'am.
are the possible outcomes where you can have a even number in the outcome? It is H2, H4, H6, T2, T4, T6. Agreed?
Yes, ma'am.
Right. So I'm asking, what is the chance of me getting a head or an even number? So what are the possible outcomes? H2, H1, H2, H3, H4, H5, H6, T2, T4 or T6, right? Head or even. So I am having the even comes with H2, so that intersection also has to be removed from it. Got it?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Okay. So now suppose the two dice are rolled. Yeah, I haven't come to independent yet. Is mutually exclusive clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Because I've not talked about conditional probability yet. Okay. Right. I've not talked about conditional probability yet. We have just talked about additional law. Additional thing, we need to understand that if two events are disjoint, the probability of the union is sum of the probabilities. If they are not disjoint and mutually exclusive are the same. I'm going to come and discuss about independence in a few minutes. Okay. Now let's test the concept. Suppose I roll two dice. There are 36 possible outcomes. All of them are equally likely. What is the probability that the sum of outcomes is equal to 6? How many outcomes satisfy this?
5.
5
outcomes.
Oh, no.
1, 5, 2, 3.
5, 2, 4, 3, 3, 4, 2, and 5.
5 by
5 on
36. Right. So these are the outcomes, right? 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. So it is 5 by 36. Is it clear?
Yeah.
Okay.
Yes, ma'am. 5 by 36.
Whenever I have these things, so now suppose I have in a sample space events which are E, F, G, and H. The total number of occurrences or outcomes in that sample space is N. Okay. Now the row totals of E are A plus B. That is A plus B of these outcomes are event E. C plus D are event F. A plus C are event G. This A is probability of E intersection G. The total number of outcomes of E and G happening. So let's apply it to our this rolling a dice and tossing a coin. E is head. F is tail. Okay. G is getting an even number and H is getting an odd number. Is that clear? Now I want you all to say that.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What is this getting a, what is E intersection F? G, it is getting a head and a even number. How many possible things? H2, H4 and H6. Is that clear?
Yes, ma'am.
Yes, ma'am.
Is the small a? 3.
3.
3.
What is small b?
That's also 3.
3.
3.
Small c?
3.
3.
3.
3.
D is also 3.
3.
What is capital M?
6.
6 or
12.
12.
12.
12.
Twelve.
Sorry, 12.
Is that clear? A plus B is 3, 6, and 12. So what is the probability of E intersection G? It is A divided by N, which is 1 by, so you all saw that it was H2, H4, H6 divided by 12. You all said it was right, the right answer, right? It is 3 by 12. Is that right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now let's ask this question. If I give you the condition that you have already got a head, okay,
Yes,
what
ma'am.
is the chance of you getting a even number? So
1
I'm
by 2.
restricting the thing. So now what
1
is
by 2.
happening to your total sample space? Suppose I already give you the information. So how many outcomes are there in the sample space, first of all?
12.
12.
12.
I'm telling you that you have a head. Head is there. So how many outcomes do you have to only see now?
6.
6.
6.
What is the chance of you getting an even number from that?
3.
1 by 2. 3 by 6.
Half.
It is 3 by 6 now.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Similarly, if I tell you that you got a tail, what is the chance of you getting a even number?
3 by
1 by
6.
2.
3 by 6.
That's
3
also
by
3 by
6.
6. So the chance of you getting a, what is the chance of you getting an even number when you're rolling a die?
1 by 2.
1 by 2.
1 by
So
2.
3
1 by 2.
Agreed.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Now let's go back to this example. Okay, this is the total possible outcomes. Yeah. Okay.
Yes, ma'am.
Now I am asking you what is, so the chance of you getting a sum of 5 was 5 by 36. 6 is 5 by 36, right?
Yes, ma'am.
What is the chance of you getting a 7?
0.
Sum of
No.
7.
6 by 30.
Sum of 7,
6
sorry.
by
Sum
36.
of
6
7,
by
sorry.
36.
It is 6 by
6
36.
by 36.
Yes, ma'am.
Yes, ma'am.
Now, can I get a sum of 7 irrespective of what was my first choice?
Yes, ma'am. Okay.
No, ma'am.
Yes.
No, ma'am. Because when it is 1, we cannot say.
Can
all
I get a, listen to the question very clearly. Can I get a sum of 7 no matter what was my first throw? Can I get it if it was a 1?
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
It was a 2,
Yes, ma'am.
Yes, ma'am.
3, 4, 5, 6.
Yes, ma'am.
Yes, whatever
Sum
be the
of
first one.
can I get a sum of 6 irrespective of whether what was the first throw?
No.
No, ma'am.
No,
No,
ma'am.
ma'am.
No, ma'am.
No, ma'am.
Can I
Yes,
get
ma'am,
a
we
sum
can
of
get it.
6 if my first throw was a 6?
No, ma'am.
No,
No,
ma'am.
ma'am.
No, 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 no.
Sum of 8?
No, ma'am.
No.
Yes, yes, ma'am. 6,
Yes,
6
ma'am.
to
6
1.
2.
In case of 1.
No, ma'am.
In
One
case
is
one is
Okay, first row is a 1. Cannot get a sum of 8, right?
Yes, ma'am.
Yes, ma'am.
Okay, right. So now, is getting a sum of 7 dependent on what was your first row?
No, ma'am.
No, ma'am.
No, ma'am.
No.
But is getting a sum of 8 dependent on what was your first row?
Yes,
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 ma'am.
ma'am.
Yes.
Sum
Yes,
of
ma'am.
6 dependent on what was your first row?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Yes, ma'am.
So
Yes, ma'am.
suppose I define an event getting sum of 7. And E1 is the event of getting a sum of 7. And E2 is the event which is the outcome of your first row. Okay. Is E1 dependent on E2?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
Suppose I define E3 is the getting a sum of 8. Is E3 dependent on E2?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes.
Okay. So now at a conceptual level, we know what is a dependent, and so now you, without any mathematics, you know what is a dependent and what is a dependent event. So can I say that getting a sum of 7 is independent of whatever was my first row?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
can say that.
You can say that, right? Okay. So notionally, what is happening to us is we are trying to find out what is the conditional probability of a particular event happening. Okay. What is the conditional probability of a particular event happening conditioned on another event? That is what we are trying to see. Is that clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So what I am trying to say here is, what is the chance? Suppose I have E1. Okay, suppose I define E1 to be my sum of throws equal to 7 and E2 to be my event that the first row or outcome of the first row. I am asking what is the chance of E1 conditioned on E2. That is what I am trying to find out. Is that clear?
Yes, ma'am.
Right.
Ma'am.
So now if I go back to this, if you look at this thing, 1 second. Okay. So if I go here, now just condition. So now I know that this E is E intersection G. E and G together happening. Is that clear?
Yes, ma'am.
Yes, ma'am.
B is E and H together happening. So that is E intersection H. That's also clear?
Yes, ma'am.
All
Yes, ma'am.
these things in the blue boxes are E intersection G, E intersection H, F intersection G, and F intersection H. Is that clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
What I want you all to see is, I'm conditioning the G happening on E. Okay. So what is G on E? That is, what is only E? How many outcomes are only E?
A plus.
A plus B?
A plus B.
A plus B, right? Only E.
Yes, ma'am.
Out of this, how
Yes,
many
ma'am.
are G? It is A divided by A plus B.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Similarly, if I am looking at H conditioned on E, what would that be?
B divided by
B by
A.
Plus B divided by B.
So what is this A? It is nothing but probability of E intersection G divided by probability of E.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We all agree? I repeat.
Yes.
What is the chance of how much of G is happening conditioned on E? It would be A divided by A plus B. Is that clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
But
ma'am.
A is nothing but probability of A divided by N is nothing but A is this probability of E. So this one, if you look at this G, okay, probability of G if I look at probability of G conditioned on E, this is what I'm trying to look at, right? This is A divided by A plus B. Would you all agree?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This I can write as A divided by N divided by A plus B divided by N.
Yes, ma'am.
Yes, ma'am.
Yes,
A by
ma'am.
N
Yes,
is
ma'am.
probability of E intersection G. A by N is probability E intersection G.
Yes, ma'am.
A plus B by
Yes,
N is
ma'am.
probability of E.
Yes, ma'am.
Yes, ma'am.
So this probability of G conditioned on E is nothing but probability of E intersection G divided by probability of E. You get it?
Yes.
Yes,
Yes,
ma'am.
ma'am.
That is what we call the conditional probability. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
so the conditional probability is nothing but probability of A intersection B divided by probability of B. Till here, is this clear?
Yes, ma'am.
Yes, ma'am.
Clear.
Yes, ma'am.
So if probability of A given B is equal to this, I can cross multiply these terms to get probability of A intersection B. So to get this probability of A intersection B is probability of A conditioned on B into probability of B. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
What was my union additional? This one was probability of A union B. So always understand that when I talk about addition, it is A or B happening. Multiplication is A and B happening. Right from addition rule of counting and multiplication rule of counting to probability formula also, right? A or B is A union B. A and B is A intersection B. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
now, if A is independent of B, right? What does this mean? Just look at this formula here. If A is independent of B, what is the probability of A happening given B, A and B? Suppose I'm talking about an event happening. A is independent of B. What is the probability of A happening by itself? It is probability of A.
Probability of this thing.
P of A.
P of A itself. If A is independent of B, will this probability change? Probability of A happening P of A change? If it is independent of B, B has no effect
No,
on
ma'am. No.
So P of A given B will remain P of A.
Yes, ma'am.
Yes, ma'am.
A is independent of B. This term would remain P of A. Would you all agree?
Yes, ma'am.
Yes, ma'am.
So what would happen to the probability of A intersection B if A is independent of B?
It will be
PA
clear.
into PB.
It would become P of A into P of B. Is it clear?
Yes, ma'am.
Yes, ma'am.
When I have
Yes, ma'am.
independent events, I have the probability of the intersection. So I say E is independent of F if probability of the intersection is the product of the probabilities. Is this clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Now, so you remember disjoint events, probability of the union is sum of the probabilities. Independent event, probability of the intersection is product of the probabilities. Is this? So multiplication, probability of intersection is product of probabilities, independence. Okay. And how did we get that independence law? We got the independence law from a definition of conditional probability. And how did we get our conditional probability? Remember this table. If you remember this table, you'll understand conditional probabilities. Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Remember this table, you'll understand conditional probability. Okay. And from that conditional probability, you know that if two events are independent, if probability of the intersection is product of the probabilities. Two events that are not independent are said to be dependent events. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So for two events, This is a if and only if condition. For 3 or more events, it becomes slightly more complicated. So when I talk about 3 or more events, I have to not only have probability of E intersection F intersection G is the product of probabilities, I also have what I call pairwise independence. What is pairwise independence? How many pairs will I have if I have E, F, G? How many pairs do I have?
1, 2, 3.
EF, EG, and FG, right? So I'll have 3
Yes,
pairs.
ma'am.
I'll have EF, EG, and FG. So in addition to probability of E intersection F intersection G, which is the product of the probabilities, I also have to have the pairwise independence. Is that clear? For 2 events.
Can you please repeat, ma'am?
See, for 2 events, when I have 2, is this clear? Probability of E intersection F is the product of the probabilities. Is this clear?
Yes, ma'am. Yes.
Now, for 2 events, this probability of intersection is product of probabilities is a if and only if condition. What is the if and only if condition? If they are independent, that the product is equal to this. If the product is equal to this, then they are independent. Okay. But for 3 events, when I'm talking about independence of 3 events are said to be independent. This alone is not sufficient condition. Is that clear? That the probability of E intersection F intersection G is the product of the probabilities. I have 3 more conditions. And what are they? Probability of pairwise independence. That probability of E intersection F should be the product of the probabilities, E intersection G and F intersection G. Is that clear now?
Yes,
This
ma'am.
first condition alone is not
Yes, ma'am,
sufficient.
please.
Okay.
Yes,
Is that clear?
Yes, ma'am.
Okay.
Yes.
Okay. Okay, I think I'll stop here because it's. Or you want me to go ahead with the law of total probability, Prashant? Or shall I stop here?
Ma'am, we can start. We can discuss this law of total probability and Bayes theorem in next.
And Bayes theorem? Okay, right.
Yeah.
Okay, so fine. I just wanted to. So now, so you can see that when I talk about, see now suppose I have an event here. Okay, I have this event here. And I decide that I have 2 mutually exclusive events. So let's look at an event that I have, for example, I have an event E, and this is E complement. Okay, because this is my sample space. If this rectangle is my event E, this rectangle is my E complement. Would you all agree? Yeah?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
ma'am.
I have an event F here. So since I started, I'll finish, Prashant. Okay. This F here. Okay. Now I can express this F as what is this shaded region here? In terms of
E intersection F.
E intersection F.
It's E intersection F, right?
Yes, ma'am.
And what is this region?
E complement intersection F.
Complement.
I can write F as F intersection E into F intersection E complement. I can do this. Now these two
Yes,
are
ma'am.
disjoint.
Yes, ma'am.
The vertical lines are disjoint from the horizontal line. They are disjoint events.
Yes.
So
Yes.
what is the probability of this union? It is the sum of the probability.
Yes, ma'am.
Because they are disjoint, it is the sum of the probability. Agreed?
Yes, ma'am.
Yes, ma'am.
Now, from the definition of conditional probability, what is F intersection C? It is probability of F conditioned on E into probability of E.
Yes, ma'am.
Yes,
Now,
ma'am.
this would be probability of F conditioned on F E complement into probability of E complement.
Yes, ma'am.
But this is, so I can write probability of F as probability of F conditioned on E complement into probability of E plus probability of F conditioned on E complement into probability of E complement. I can do this, right? Now let's apply this. Where would we apply this? Suppose I have a company which is getting spare parts from the same spare parts from two companies. Let me call it A and B. There is a 30% chance that the spare parts come from A. There's a 70% chance that the spare parts come from B. Okay. Now let this F be the chance of me finding a defective spare part. Is that clear? So what is this even D intersection A? Express this even D intersection A. What is D intersection A? It is a express it. Articulate what is D intersection A. D is the event of a element being defective and A is element coming from A. What is D intersection A?
It is the defective
Probability of finding coming from A.
And it is coming from A, right? What is D intersection B?
Defective element coming
from B company.
And coming from B. So what is the chance of an element being defective? It is equal to probability of a defective. I'm just applying this formula. Conditioned on it comes from A into probability of A. Okay. And I also say that the chance of an element being defective from A is 2% and B being defective is 3%. Okay, the defective rate of B's company B is 3%. So what is probability of D given A? Probability
2%.
of D being defective given the information is from A. It is 2%, which is 0.02.
Yes, ma'am.
Probability it comes from A is 30%, that is 0.3.
0.3.
Yes, ma'am.
Plus probability of D coming from B into probability of B. What is probability of D coming from B? 3%, right?
0.0.
0.03 into 0.7, right?
Yes, ma'am.
Yes, ma'am.
Yes.
So this is the chance of it being defective. So far it is clear. This is what is called the
Yes, ma'am.
law of total probability. Now we can add another company also. 30% from A, 30% from B, and 40% from C. Right?
Yes,
Then
ma'am.
what would be that? What else do you need to know here? I need to know what is the chance of it being defective that it comes from C. Says, let me say it is 1%. So what is the chance of it being defective here? This will become 0.3 plus what is the probability of D given C?
0.001.
0.1 only, right? 1%.
Oh, yes, 0.1.
And into 0.4, right?
Yes, ma'am.
Is it clear? So this is the chance of it being defective. So far so good?
Yes, ma'am.
So this is the law of total probability. Now suppose I have come to my company and I mix all my spare parts together. Okay? I've got 100 spare parts. What is the chance it comes from A? I pick up one part. What is the chance that this part comes from A?
0.3%.
30%, right? 30%.
30%.
30%.
I pick up. What is the chance it comes from B?
30%.
What is the chance it comes from C?
70%, ma'am.
40%.
No. Now I made A, B, C, right? 30% from A, 30% from B, and 40% from C. Okay. Now I pick up an element. I notice it is defective. I repeat, I pick up a part. I notice it is defective. I want to know. So what is the information that is given to you? You are conditioning this on what event? I know it is defective. I want to know the chance it came from A. Is this clear? So
Yes.
without this
Yes, ma'am.
information, when I just picked up a part, what was the chance it came from A? It was 30%. Now I have additional information. What is the additional information I have about this part?
Sorry,
Part is
defective.
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 Defective. Now I want to know that given it is defective, what is the chance it came from A? So what is this? I apply Bayes theorem. What is Bayes theorem? Again, I know this is probability of D given A into probability of A divided by probability of D. This is what is my, from conditional probability, this is what it is. But what is probability of D? This is probability of D, right?
Yes, ma'am.
Agreed? Yes, I can apply Bayes theorem. What is probability of D given A? 0.02. Agreed?
Yes, ma'am.
2.3 divided by probability of defective. That would be, that is what Bayes theorem uses. Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Clear.
ma'am.
Knowing the law of total probability, I get what is Bayes theorem. Is this clear? Okay.
Yes,
So I
ma'am.
think we will stop here. Okay, it's already past 10. I hope you found this session of some use. Okay.
Yes, ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
as I mentioned earlier, if for in future, whenever there's a session announced, so Prashant, you can also take care. If there are any specific questions, you please see. Most of my sessions would be at a conceptual level clearing. It is not a problem solving or anything here. Okay. Is that clear?
Yes,
So,
ma'am.
Yes,
Yes,
ma'am.
ma'am.
any specific problems to be addressed or something of that kind, you can always send it to the team and we will take it up and we'll see how to address it. Okay. Thank you all. Okay.
Yeah,
I'll
thank you,
share
ma'am.
the slides. Definitely, I'll share the
Thank you, ma'am.
slides.
Good luck, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you very much.
Ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you. Bye.
Thank you, ma'am.
Bye.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.